There are many types of electrical equipment is widely used around the world, and battery is known as an essential part in the field of electricity. We will look at the difference between a cell and a battery when most diverse see a device like this. The chemical cells is actually defined as a combination of two or more chemical cells connected to each other. For example, if we take the positive and one cell to the negative and have another cell make yes, it's formed of batteries of two cells in series. The voltage of a cell is measured of how much potential energy electron gas they go through a cell. Many common cells have a voltage of 1.5 volts. When cells are connected in series or in parallel, each cell adds potential energy to the electrons go through it.
Batteries are classified into primary and secondary forms. Primary batteries irreversibly transform chemical energy to electrical energy. When the supply of reactants is exhausted, energy cannot be readily restored to the battery. Primary batteries or primary cells can produce current immediately on assembly. These are most commonly used in portable devices that have low current drain or are used well away from an alternative power source, such as in alarm and communication circuits, where other electric power is only immediately available. Secondary batteries, also known as secondary cells or rechargeable batteries, they can be recharged. This means that they can have their chemical reactions reversed by supplying electrical energy to the cell, approximately restoring their original composition. They are usually assembled with active materials in the discharge state. Rechargeable batteries are recharged by applying electric current, which reverses the chemical reactions that occur during discharge or use. Devices to supply the appropriate current are called chargers. Here is the table that's used to compare these two kinds of batteries. First is about the cost. Primary cells have lower initial cost than secondary batteries. And another factor is that the secondary batteries require regular maintenance and periodic recharging, while the primary cells are disposable. Primary batteries are typically lighter and smaller, thus they are traditionally more suited for portable applications. And the secondary batteries are traditionally less suited for portable applications, although recent advances in lithium battery technology have led to the development of smaller or lighter secondary batteries. Primary batteries have longer service per charge and good charge retention, while the secondary cells are relative to primary battery systems. Traditional secondary batteries is a bit inferior charge retention. Primary batteries are not ideally suited for heavy load or high discharge rate performance, when the secondary cells have superior high discharge rate performance as heavy loads. And the secondary battery are ideally suited for load leveling, emergency backup, hybrid battery, and high-cost military applications. When the primary cells are not ideally suited for these applications. Primary batteries are traditionally limited to specific applications. The overall inherent versatility of secondary battery systems allows its use and continuing research for a large spectrum of applications. And here are the common types of batteries. Common types of disposable batteries include zinc air, zinc carbon, lithium, alkaline, etc. And cells of secondary batteries include nickel-cadmium, nickel-manganese hydride, lithium-ion, lead acid, and etc.
The final one, we move on to the function of battery tactor. The power to drive an electronic circuit is normally provided by an AC main power supply, but batteries are often used for portable equipment. People contact it a battery tactor. Battery tactor can be recharged to 12 or 3 voltage and can therefore be used many times over. As you can see in the picture, this is the block diagram of battery tactor. In the battery tactor, we have transformer, rectifier, smoothing circuit, and stabilizing. Let's see the function of each block in the diagram of a battery tactor. The first stage consists of a transformer which step down the voltage of the AC main. The second stage is a rectifier. Rectifier converts the AC voltage to the DC voltage. The third stage is a smoothing circuit. It removes the fluctuation in the DC output of the rectifier. It consists of a electrolytic capacitor connected in a parallel with a rectifier, and the final stage is a stabilizing circuit. Stabilizing circuit consists of a transistor biased by two resistors and the Raney diode. This prevents the output from the changing when the load varies.